In this video, we're going to see how to complete a hypothesis test for a single population proportion by using Excel. So this question says, suppose that 232 subjects are treated with a drug that is used to treat pain and 50 of them developed nausea. Use a 0.01 significance level to test the claim that more than 20% of users develop nausea. So the first thing we need to do is identify the null and alternative hypothesis. What we want to look for when we're trying to do this is whatever the claim is. So this question said that the claim is that more than 20% of users develop nausea. Typically when we do a hypothesis test, we are not working with percentages, we are working with proportions, which basically just means the decimal version of the percentage. So 20% as a decimal is 0.20. So we're looking for something in our hypothesis where a claim is being represented that a proportion is more than 20% or more than 0.2. When we come here to our options, we have to remember that H0, the null hypothesis, always has an equal sign in it, always. So I already know that letter D is not the answer, because even though I see that greater than sign, it's in the wrong place. The null hypothesis always has an equal sign in it. So the correct answer should be letter C, because the null hypothesis has an equal sign in it and says that P, the proportion, is equal to 20%, 0.2, and the alternative hypothesis has the claim we were looking for, that P is greater than 0.2 or 20%. And in this case, the alternative hypothesis is the one that is holding our claim. So now we need to find the test statistic for this particular hypothesis test. Now in Excel, there is not necessarily an easy or straightforward way to do this, so we're going to have to compute a few things, quote unquote, by hand or by making our own formulas in Excel. There are some add-ins that you can purchase to add to Excel, which will make this a lot easier, but we're not buying those for this class. You're welcome to look up some videos that show you how to use things like Excel Stat if you're interested in that and have access to it. But this time we're just going to go ahead and come up with our own formulas. So this is the formula for the test statistic. It's going to be a z-value, and the formula is p hat, which is the sample proportion, minus p. P is the value in our claim, that was the 0.2, divided by the square root of p, 0.2, times q. Q is 1 minus p, divided by n, which is the sample size. So first let's go ahead and come up with what all those things are, and let's label them over here. So p hat, or p with a caret if you prefer, that's just going to be the sample proportion that we got from the question. So if we go back to the question, we remember that we had 232 subjects in the sample, and of them, 50 developed nausea. So 50 over 232 is going to be our sample proportion. So we start with an equal sign to make our own formula, and we're going to do 50 divided by 232, and we hit enter. So there's our sample proportion p hat. The p, no hat, that is the proportion that we're making the claim about. So that in this case was 0.2. Remember we had the 0.2 here. That's because our claim was that more than 20% develop nausea. The other thing we needed was the q. So we can do the q here if we like. Remember, q is just 1 minus p. So we can make a little formula starting with an equal sign and do 1 minus and then just click on the value that we had for p above. So there's our q. And finally we had n. That was the sample size. So again, that was 232. We had 232 people in our sample. So now to do the test statistic, we're just going to try to create this formula right here by making our own formula in Excel. Every formula starts with an equal sign, so we're going to start with an equal sign, and then in parentheses at the top, we're going to do p hat, which was this guy, so we just click on it, and Excel will bring the number in that cell right over into the formula, minus p, which was this guy, right, p hat minus p in the numerator, and we close the parentheses to close off that numerator, divided by, now to do a square root, we type SQRT and open a set of parentheses. Under the square root, hence inside the parentheses, we're going to have P times Q divided by N. So P times Q divided by N. Again, we just click on the cell where the numbers for these different variables are being housed. close the parentheses, and hit enter. So here is our test statistic. Our test statistic is going to be 0.590879, and let's see how many decimals we wanted to round to. This question wants us to round the test statistic to 2 decimal places. So if we come back to Excel, we can do that ourselves, or if we want Excel to do it, we can go up to the Home tab and come over here, and these buttons right here will either increase or decrease the number of decimal places we have. So we want to decrease this down to 2. So there's 2. So 0.59 will be our test statistic. Now we need to find the p-value. So to find the p-value, it depends on whether you have a left-tailed, right-tailed, or two-tailed test. If you have a left-tailed test, you're going to use the norm-dist function that we first used in a previous chapter. If you have a right-tailed test, you're going to do 1 minus the norm-dist function. That's because the function in Excel is always giving us the area to the left. So if we have a right-tailed test, we just need to adjust for that by finding the complement of the area to the left. And if we have a two-tailed test, the formula will depend on whether our test statistic was negative or positive. If it was negative, it would be this, 2 times the norm-dist function, and if it was positive, it would be this, 2 times 1 minus the norm-dist function. So in this case, we had a right-tailed test. We know it's a right-tailed test because the direction of the inequality in our alternative hypothesis was a greater than sign. You can kind of think of that like it's an arrow. If that was an arrow, it'd be pointing to the right. So this is going to be a right-tailed test. So hence we're going to use this formula right here, 1 minus norm-dist. So for the p-value, we're going to start a formula and go 1 minus. You can type norm-dist right here, or you can go up to formulas, more functions, statistical, and down to the end section and find the norm-dist function right here. So the first thing the function wants to know is what is the x? The x in this case is going to be the test statistic. So we can just click right there on the test statistic that we found earlier. The mean and standard deviation are going to be 0 and 1 because we're looking for a z-score. That means the standard normal distribution. In that case, the mean is always 0. The standard deviation is always 1. And for cumulative, we'd like to type true because we do want this to give us a cumulative area. So if we click OK, we get the p-value right here, this very long decimal, 0.277, etc. So let's go back to our question and see how many decimal places we wanted. This said to round to 3 decimal places. So again, we can come here to the Home tab, and way over here, this button right here will decrease. We just keep clicking until we have the number of desired decimal places. We wanted 3, so here's 3. 0.277 will be our p-value. So now we have to make a decision about what we're going to do regarding our original claim. Well, what we do to determine whether we reject or fail to reject the null hypothesis is we're going to compare the p-value we got to the significance level. So here the p-value was 0.277, and remember the question told us that we were supposed to use a 0.01 significance level. So the rule is if the p-value is less than the significance level, you will reject the null hypothesis, reject H0. Otherwise, if the p-value is greater than the significance level, you will fail to reject H0. So in this case, our p-value, 0.277, is definitely a lot bigger than the test statistic of 0.01. So we know we're going to fail to reject H0. So I already know that A and B are not going to be the answer because those both say to reject H0. So it has to be either C or D. So now let's go one step further. Going back to what our original claim was, these were the statements we set up for our null and alternative hypothesis. The null hypothesis said that the proportion, meaning the proportion of people who developed nausea when taking this drug, was equal to 20% or 0.2. And the alternative hypothesis said that the proportion was actually greater than 0.2. We have just decided to fail to reject the null hypothesis. We are not going to reject the null hypothesis. As far as we're concerned, that statement could be true. Well, if I did not reject the null hypothesis saying that the proportion was equal to 20%, then I have not supported the claim that the proportion is greater than 20%. So looking down here, we would choose letter C. We failed to reject the null hypothesis. There is not sufficient evidence to warrant support of the claim that more than 20% of users develop nausea.